Morning, guys. So today we'll be starting with a new chapter, right? I hope you have understood the last chapter, chapter 6, work energy and power. As you can see, that chapter was easy, right? Simple formula, simple concept, and easy to calculate and to understand also. So the next chapter which we are going to deal is chapter 7, which is system of particles and rotatory motion or rotational motion. Okay. Oh, color change within fraction of a second. Okay. Particles and rotational motion. Okay. This chapter question is both important in your CBSE point of view because it is consisting of a vast, it is a very large topic, okay, with plenty of numerical section. That's why damn sure in NEET or any entrance examination more than 2 questions are seen from this chapter. So it carries a very good weightage as per NEET as well as any entrance examination is seen. So give importance to this chapter and understand the concept because equations are there which has to be mucked up. But along with it, I will tell you some of the things which can be solved by just theory itself. Okay, so those and all concepts you have to clarify so that you can understand the entire chapter. Okay, so before moving to this chapter, I want to say that mention that actually this is a continuation of your all the 6 chapters which you have learned till now. Okay, that is, suppose till now you always considered an object, right? When you were talking about Newton's law, etc., when you talked about 3 kilogram of mass, you drew a block, right, and you said this 3 kilogram mass is exerting a weight downwards which is 3g, which experiences a no reaction from the ground where it is placed. This and all has been taught, right? So what actually happened is this 3 kilogram is not for this entire mass, not for the means it is actually for the entire mass, but this particle, suppose I consider this particle here inside this mass is not having 3 kilogram, right? Similarly, this another particle inside this mass doesn't have 3 kilogram. 3 kilogram is actually the mass of the entire block, right? So that means till now actually in place of this entire block I had been considering this block as a point mass. I considered that this 3 kilogram block I actually consider as a point mass, and then I drew the our free body diagram. This is how actually we did, right? So moving on, so that means we actually considered a body never as an entire system but actually as a point object. But in real life we know that in real life object is not point, right? It will be of huge mass and shape and size. So actually you're supposed to say that object or any object in the universe is a collection of small particles, right? Or I can say in real life any object is a system of particles, right? Or collection of particles, as this chapter's name suggests, we can say it as system of particles, right? And we are going to study this system of particles, what its nature will be, what will happen if it is having motion, etc. Okay, so before moving on to the main section, there are some few terms which you have to learn and understand. First is a rigid body. What do you mean by a body versus rigid? How can I define a body as rigid or not? See, the definition is it is a collection of large number of point masses in which the separation between any two consecutive particles is fixed. I hope you didn't understand. I'll tell you again. Suppose this is an object. I say it is rigid if it is a collection of large number of point masses, right? There are different particles and each particle has its own small masses, and total becomes its equivalent total mass, right? So suppose there is a collection of masses for this object, right? And let's say I'm considering the particle here and another particle here. If the separation between them is d, right, I exert a force, external force over it like this, right? So if the distance between these two particles doesn't change, then I would say this is a rigid body. If you say consider a sponge, right? Let's say sponge, I'm going to redraw. This is sponge if it is. And after application of the force, what happens? the shape of the sponge becomes like this. So initially if the particles have been this one, right, and the distance was d, now the distance would have become d dash, right? The distance between the points reduces. So this is not a rigid body, whereas this is a rigid body. Example, brick, right? See, if you consider brick, when you consider these two particles, when you exert a limited amount of force, right, if I apply, the distance between the particles doesn't change, so it is a rigid body. So then you would say brick can be broken, right, if I exert a lot of force over it, right? So that's why in universe no body is perfectly rigid, right? Every object can be said to be rigid for a limited amount of force. Okay, right? So this any rigid body in our universe is having three different types of motion. First one is translational motion. Translational motion. In Malayalam it is nerangi puva. Nerangi puva. Right. So what do you mean by translation motion? So this is an inclined plane. If I am having a block over here, it just drags over the surface, right? So this type of motion is known as translational motion. What is the, no, in physics, how can you define? See, in this type of motion, see, this is a particle over here surface, in this surface also another particle. There are millions of particles during the, or where there is a contact, right? So this block, if I separately draw these particles, right, all of them are having velocity in this direction, right, and all of them are having same magnitude, right? So during a motion, translational motion, if all the particles of contact or the entire particles inside the body is having same velocity in magnitude and direction, then I would say that motion is translation, right? Now the second type is rotational motion. Rotational motion, this and all are CBSE point of view question chapters, okay, right, or topics. Rotational motion, that also you know actually. What do you mean by rotational motion? This is a circular motion, right? Suppose the center is here, okay. A particle, if I consider, obviously this is a collection of particles, this disk, or I can say this is disk, okay. So disk is a collection of particles. There are through particles over here, right? So let us consider this particle over here. I'm going to rotate it in this direction, right? So this particle will be having velocity in this direction, right, whereas this particle will be having velocity in this direction. Then another particle, will be having velocity in this direction, right? So this particle will be having this direction, right? So I can say that this particle 1 2 3 4, all of them are having velocities in different directions, right? So velocity is having different directions on the edges, right? So on the edges, the velocity of the particles are, or the particles which are on the edges of the disk are having velocity in same magnitude. Why? P is equal to r omega, right? All the particles are equidistant from the center. So V is equal to r omega is constant. Omega is the angular velocity of rotation, right? So V's magnitude is same, but the direction changes, right? Clear? But there is another point here. This is regarding the particles which are on the surface, or I can say rim of the disk. What happens if the particle I am considering is here, not on the rim? It is at its lower distance from the center, right? That is r is less. So r is less means V is equal to r omega. When r reduces, V also reduces. So the particle which is here will have lower velocity. Again, a particle which is here will have lower velocity. That means a particle which is at the center will have zero velocity, right? So each particle, depending upon the position on the rotating disk, is having different velocities as well as different directions. Clear? So in translation motion, the body will be having equal velocity. All the masses inside the body will be having same velocity in the same direction, whereas object rigid body is said to be in rotational motion if all the velocities or all the particles in the object is having different velocities and in different direction. Okay, simple, right? So there is another scenario where there can happen combination of both translational and rotational motion, that is rotational as well as translational motion. This is very easy. Same inclined plane you are considering. Let's say this is a wheel, Okay, the wheel, if you're considering, let's say that wheel is having a center, or you can say disc itself if you want, right? Let's say combination of rotation and translation motion is known as rolling motion. This is the disc, right? It is rotating, right? When it is rotating, each particle in its rim, right, is having what? Different velocities, direction, but same magnitude. Now a particle here close to center will be having different velocity, which is less than that of the same rim velocities. Yes, whereas the particle which is at the center will be moving constantly in this direction, right. That means particle now in the center is not having zero velocity, it is having zero rotational velocity. That is at the center particles. Okay, I'm telling about center. The particles which are in the center have zero rotatory velocity, but they have translational velocity, not zero, sorry, it is not zero, right? The center particles are having zero rotatory velocity, but they have non-zero translational velocity. Clear? These are the three types of velocities of a rigid body. This is all our introduction parts, guys. Before understanding or going to the main concept, you have to understand the basics. Okay, so what is actually a characteristic of rotational body? If someone asks you, that is, I'm going to draw a irregular rigid body. Let's say it is rotating like this about its axis of rotation. This is axis of rotation. Just like your earth is rotating about its axis, this is called its axis of rotation. This rigid body is rotating in this direction. I'm going to cut a part of it like this, right? So that now the top view, if you are considering, let's say it is a circular cutting, right? So again, this is your axis of, not your, this body is axis of rotation, right? This is your, or that particles, or this body is what? Plane of rotation. This and all term you have to know, plane of rotation, because if you consider two particles along here, right, these two particles inside it, right, this both particles are undergoing a circular motion like this, right, and it is about this plane, right? So that's why this plane is called, which one? This plane is called plane of rotation, right? So you can see that during a circular motion or rotational motion, the axis of rotation, which is this one, is perpendicular to the plane of rotation. Keep that in mind, right? So every time in rotational motion, the axis of rotation is perpendicular to the plane of rotation. Clear? Right? So that is, suppose in the same diagram, okay, I'm going to redraw it, only the top part, okay, that is this circular section, right? This I can name it as X plane, right? Let us name this one as Y plane. So obviously this will be Z plane, right? So okay, actually this was supposed to be in center, I'm sorry. Redraw it like this. Okay, now it looks somewhat to the center, even if this doesn't look like a circle. Okay, anyways, so this becomes the axis of rotation, right? Along this one, this is Z axis becomes the axis of rotation, and the plane of rotation is XY plane, right? Right? Clear? Right. So similarly going on, right? Suppose the same rigid body I'm having, right, and you are having an axis of rotation, let's say it is AB, right? Let's say it is rotating like this. Now suppose what happens, these 2 points are fixed. That means the axis of rotation, this is constant. That means the object can, sorry, I drew it like this now. Okay, let's redraw it. Let's say this is AB and I am keeping this AB fixed, right? So, and I'm rotating this object, means now it is a pure rotatory motion. This AB is fixed, it doesn't move, right? It's just like you are having a pen, right? Put a ring over it, right? And this axis is not allowed to move like this or anyway, right? This ring can only rotate. Clear? Just giving an example, right? So but this scenario also can be changed. You would have seen top, right? What do you mean by top? Pambaram, right? Okay, top means, oh, I hope you understood. Malayalam is not supposed to be included, but I don't believe you might, some of you guys might not understand what top is, because so normally in our language top means pen stop, not that one. I'm talking about Pambaram. So suppose you are considering, you have a perfect figure in your textbook. Okay, so I'm just drawing rough figure. So this is your top. Okay, this part is on your ground like this, right? Its axis of rotation is actually this one, right? Let's name it as A and B. That means one point of axis of rotation is hinged, or I can say it is what? Stagnant. So but one point is free to rotate, right? That means when A rotation, or I can say this axis of rotation I am reading, okay, that is I am redrawing the plane in which it will be rotating. It will look like this. See, that is when you are just considering the top which is rotating, just consider this AB line. That time you don't require to remember, okay, I'm going to rub this one. So this is the axis, right? This axis also rotate in this direction, like this, right? But similarly your top is also spinning, right? This was your top, right? The top was also spinning, right? Suppose the top is rotating in this direction, right? That means AB, you can see that AB will be rotating in this direction. That is, if top, right, is rotating in clockwise direction, then the axis will be rotating in anti-clockwise direction, right? Similarly, you would have seen in the case of fan, this and all happens. This and all are the example of rotatory motion where one axis is hinged. Okay, your table fan, right? I'm just drawing it, okay, right? So when this part, that is the center part, right, that if it is rotating, if I am extending, this becomes the axis of rotation of the fan, right? So if the axis of rotation is in this direction, then the leaf will be rotating in this direction, right? So axis, when it is rotating, right, at one hinged side, the other part of the object will be oppositely rotating. So yeah, this and all are some of the examples which has been notified in your textbook, right? Now the important concept which you have to learn during this chapter is center of mass, right? Center of mass. So what do you mean by center of mass? So its proper definition is point in an object inside or outside the object where the mass of the object is assumed to be concentrated is said to be center of mass. That is, suppose I'm just giving an example. You're having a regular body. So let's say like this, or no, I will take like this. This mass, let's say, is a regular rectangular body, okay, and it is having throughout lot of particles like this, right? Each particle is having small masses dm, 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 etc. So it is very difficult to consider the mass of individual particles, right? So in order to make this calculation of the mass, or in order to calculate many other criteria like force, acceleration, etc., we consider that the mass is not distributed, or even if the mass is distributed in conventional way, we are going to assume that those mass which is of the individual particles is actually concentrated to an imaginary point, say like this, right? This mass is, or this point is known as center of mass, right? An arbitrary or an imaginary point inside or outside the body where we assume that all the mass of the object is concentrated, that is known as center of mass, right? Because we already talked about that any object or any body is system of particles, right? So to study the motion of the body, it is difficult to study the motion of each particles, right? So it is better to assume a point, right, where you can say that actually the mass is concentrated over there, and then you can calculate, right? See, there is a very good example in your textbook, that is with a jug, etc. I will talk about a pen, right? Suppose this is your pen, right? You're throwing the pen like this, right? So later on the pen can move like this, right? Then the pen will move like this, right? While it falls, it might fall like this, right? The rest of the four positions of the pen. So each particle, see, this particle will be having different velocity here, different velocity here, different velocity here. Similarly, this point will be having different velocity here, different velocity here, different velocity here, right? But just assume the center of this pen, right? The center of the pen is actually undergoing a proper projectile motion, right? Each particle will be having a projectile motion. That is what we have learned, right? So it is easier to study about the center of mass of this, or the motion of the center of mass of this pen, rather than studying each and every individual particles. Clear? Right? So this and all are the things which helps us to calculate, or to calculate the motion of an object. Right. Similarly, this and all are example, and I'm just giving you an introduction. We have not yet reached the center of mass concept in detail. Okay. Suppose I'm going to consider a solid disk. The disk doesn't look like one. Oh, I could have taken the circle, na? Yeah. Right. Right, this is your disk. Okay, let's say the disk is rotating with an angular velocity omega, right? And you know the center of the disk will be having a constant velocity v, right? Suppose this is achieved by applying a force F, right? A force F was applied so that this disk started to rotate with the angular velocity omega, and the center is having a translational velocity v, right? This much clear? So if someone asks you what the magnitude of net force, that is this force value, how would you calculate? F net is equal to m into a. Now what acceleration I would write? Should I write the acceleration of this particle, or this particle, or this particle, or this particle? What would you do? No, it is very difficult, because this one will be having some another acceleration, this one different, this one different, this one different. So better to find the acceleration of what? Acceleration of center of mass. Clear? Right? Similarly, if someone asks you the momentum of the disk, better to find mass into velocity of center of mass. Right? Clear? So this and all is a criteria which we can simplify by calculating center of mass. So the next question comes, how to determine center of mass? How can you find the center of mass? If it had been like this, you are having a rod, right? Let's say the rod is having mass m, right? So this is a uniform rod. Let's say this rod is having length d, right? Someone asks you where will be the center of mass. It is a common sense that you can exactly say it is at the center. It is d by 2 distance from either ends, right? If you want to check, you can use a ruler, right? Use a ruler. Ruler means scale. Keep it on your finger like this, right? Exactly at the center, you will feel that the ruler is balanced, right? I'm just giving an example. Okay, so you can say that a perfectly uniform rigid body will be having the center of mass at the center, right? Human body has not it's not uniform, right? So you consider, I'm just giving an example, this is not in your textbook. So when you are considered in your body, the center of mass is actually near to your waist or abdomen. Okay, clear? So okay, so this point which I have become or marked is known as is the center of mass of this object. Now I'm going to change a question. That is, suppose there is a mass m here, there is a double mass 2m here, right? And they are connected like this, right? So where will be the center of mass will be? That is, again, keep your finger like this, right? This is your hand, I can't believe, right? So when you're keeping the finger, you can just see when you keep here, this will be falling down, right? Then again, you will keep your finger here, right? So you will see, or it is practically you would have seen that center of mass, or when you keep the finger close to 2m, then you will see that both of the sides are balanced. That means center of mass is closer to a larger mass. Clear? right? So this is very difficult. You have to have a perfect equation by which you can say find the scenario. You need not find no, you do not find the assumptions, or you need not do the assumptions. That's why we are going to introduce what is known as formula of center of mass. Okay, suppose we are going to take an axis. Okay, let's say this is the origin here. Let's say m1 is at a position r1 from the origin, and there is another mass m2 at a position of r2 vector. Okay, both of them are vector, r2 vector, position vector r1 vector, and m2 is having position vector r2 vector. Let's say this is the line joining these two masses, right, clear? So its center of mass obviously will be lying in between them. Let's say that center of mass is at a position vector RCOM, right? This is a position vector of the center of mass. Then the equation for this center of mass position, that is RCOM vector, is equal to m1, right, mass, first mass. This is for two particle system. Okay, so m1 r1 plus m2 r2 divided by m1 plus m2. This is for two particle system, guys. When there are multiple particles, then it is m3 plus m3 r3 plus m4 r4 divided by m1 plus m2 plus m3 plus m4, like that goes on. Right, easy, right? In your textbook, the derivation or the equation is written in something different way. That is, if this is the position like this, right, if this is the origin, and for a two particle system, this is m1, this is m2, right? So let's say its distance here is x1 0, right? This position will be x2 0. Why? There is no y coordinate, right? So m1's and m2's center of mass, because this is an object like this, okay, and that object has only two particles, which is m1 and m2. That's what is called as system of two particles. Okay, so this particle is of the mass, this object, okay, this particle of the object, this one. Let's say I will name this object as A, right? Let's say A is made up of only two particles, m1 and m2. Let's say this particle of A is at a distance x1 from the origin, m2 is at a distance x2 from the origin. Then the center of mass obviously will be lying between m1 and m2. Usually it is so. So xcom, that is, why did I write it as xcom? That is the position in the x coordinate, right? This will be the position, might be, right? So xcom is equal to m1 x1 plus m2 x2 divided by m1 plus m2. This is how your textbook have mentioned it, right? Now if this I have drawn like this, right, very simple, it is having x1 and x2 coordinates only, there is no y coordinate. So the question can come if the object is having a position like this, right? This is mass m1 and this is mass m2, so it can have what, both x1 and y1 coordinate, right? This will be x1 coordinate, this will be y1 coordinate. This particle will be having x1 coordinate, sorry, x2 coordinate here and y2 coordinate here, right? It can happen, right? See, the same scenario, this is y-axis and this is x-axis, and this is origin 0 0. Let's say we are having an object like this, which is having two particles like this. This is having m1, this is m2. Now m1 is having coordinate x1 here, y1 here. m2 will be having its coordinate x2 here and y2 here. So the center of mass will be also lying between them around here, right? So this center of mass will be also having x coordinate and y coordinate, right? So similarly, so we just wrote for x coordinate center of mass, that is xcom is equal to m1 x1 plus m2 x2 divided by m1 plus m2, right? Similarly, you can write for ycom, that is coordinate of center of mass in the y direction, which is m1 y1 plus m2 y2 divided by m1 plus m2. Now can't you write for the z coordinate also? ZCOM is equal to m1z1 plus m2z2 divided by m1 plus m2. Very easy if you understand it, right? In vector form it becomes m1 r1 vector plus m2 r2 vector divided by m1 plus m2, right? Clear? Now using this equation we'll do some problems, right? Suppose you are given like this is mass m, right, and another mass 2m, right? Let's say this is origin, right, and position of m is given as 1 0 and position of 2 4 is given as 4 0, right? And you are asked what is the center of mass location, right? So obviously center of mass will be closer to this guy, right? Center of mass of this object, okay, this is the coordinates or this is the body, not from here. So always you have to fix a origin before calculating the center of mass, okay? That I will teach you later on. So what will be the center of mass position? So is there any y coordinate? No. So y COM, that is y coordinate is 0 for the center of mass. So question comes for x coordinate, right? So it is m1 x1 plus m2 x2 divided by m1 plus m2. Simple. So just substitute it. m1 is m, x1 is 1 plus m2 is 2m, x2 is 4 divided by m plus 2m is 3m, right? So m plus 8m, that is 9m by 3m. So mm cancel, you will get 3, right? So this coordinate of center of mass is 3 0. Simple, right? That is, this coordinate is at what, around 3 from the origin, or I can say 2 from this mass, right? 3 from the origin, the measurement is from origin, right? 3 centimeter, let's say 3 centimeter, 3 centimeter from origin, or I can say 2 centimeter from here, or it is 1 centimeter away from 2m. So you can say in any ways, right? Now similarly we'll do another pretty simple, right? Let's say you are not given the origin, you are just given there is a mass m here, there is a triple mass, that is 3m here, which is, and they are both at a distance d. Find the center of mass location. So you have been told you have to have a origin. So what would you do? Keep any of the mass as origin. You can keep this one or this one, no question, but I am taking this one as origin, okay? So that if this is 0 0, so this will be what, d0, its position 3m. Now it is easy, xcom, there is no ycom because both the masses are having only x coordinates. xcom is equal to m1 x1, that is m into 0, plus m2 x2 is 3m into d divided by m1 plus m2 is m plus 3m is 4m, right? That is 3m d divided by 4m. So cancel mm. So you will get 3d by 4 as the position of center of mass. That is from here, right? You measure from the origin. It is 3d by 4 distance, right? This x which I have marked is your x center of mass, right? If 3d by 4 is the distance of the center of mass from this mass, then it is d by 4 away from 3m, right? So that means the center of mass is closer to 3m, right? I hope this much is clear, right? Now let us say we are doing a lot of problems, or I am doing a lot of problems to make sure that you understand the center of mass concept, because without understanding the concept you cannot go for moment of inertia, etc. Okay, suppose this is 4m, this is m and 2m, and this is mass 3m, right? And say this and all are positioned at inches of a square, right? And you are asked what is the center of mass of this system having 4 particles, right? So how would you do? Just like the previous cases, always take one mass as origin. So let us take this, I am taking this one as origin, you guys can take this one also, there is no wrong, right? Clear? So just listen or measure the distance, or if I am telling the measurement, it is always measured with respect to this mass 3m. When you take this as origin, then you will be taking the measurement with respect to 4m. That's the only difference. Okay, okay, we have asked what is the center of mass. First point, see guys, some logic has to be understood. This side is having only 2m plus m 3m mass, this side is having 4m plus 3m 7m mass, so obviously the center of mass will be closer to this area. That's the first point, right? Now let's calculate, right? So first you have to have the coordinates. If this is 0 0, so what will be here? A 0, right? There is no y coordinate here because this is x here and this will be y, right? So I'm removing that part. Okay, so this is a0. So what will be this one? This mass m's coordinate will be what? It is having y coordinate as well as x coordinate, right? So it is a, right? So what will be the coordinate of 2m? It will be only having y coordinate, no x coordinate, so 0 a, right? So you got all the coordinates of the masses, right? So you guys can go for the calculation. So how would you do? m1 x1, right? So x center of mass, right? Both x center of mass and y center of mass you have to find. Let's start with this one. 3m into its coordinate is 0, right? m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 whole divided by 2m plus m 3m plus 4m 7m plus 3m is 10m, right? m1 plus m2 plus m3 plus m4. So when you calculate this guy and this guy's goes off, so 5ma divided by 10m, that is you get 0.5, right? 1 by 2, right? So 0.5a, that is the coordinate of x, right? Of center of mass x coordinate, that is 0.5 will be around here now, right? That becomes x coordinate, right? Now let's move on. Let us find the y coordinate of center of mass, right? That is m1 y1, that is 3m into 0 plus 4m into 0 plus m into a plus 2m into a, m into a plus 2m into a whole divided by total mass is 10m, right? So this term goes off, so that is 3ma divided by 10m, so mm cancels out, so it is 0.3a, right? That is a coordinate of y cm. So what will, this is a y axis, right? So this one section is full a, means 0.3m will be here, right? This will be 0.3a. So let us meet these 2 points. So this becomes the center of mass, right, of this object, that is at a coordinate of 0.5a from x-axis, and on y-axis it is 0.3a. This is the coordinate of center of mass of this object. Simple, right? Similarly, if the same type of question I'm asking regarding a triangular lamina, right, equilateral triangular lamina, let's say this is mass m here, okay, all the masses are m, right, and each side of the equilateral triangle is a, right, and you are asked what is the center of mass coordinates. How would you do? So this is something common sense. Again, this is only mass m, here two sides are having mm, so 2m, so center of coordinate or center of mass will be quite closest to this area, right? That is the first point which you have to think. The second thing is you have to take an origin. Let's take this part as origin, so this will be a0, right? This guy, this mass coordinate will be in x, this becomes your y-axis and this becomes your x-axis, right? Okay, so here what will be the value? This is a by 2, right? And this is also a by 2, so in x coordinate it is having a by 2. And y coordinate, what will be its value? This will be the y coordinate now. So that is the height of an equilateral triangle. I hope you know what is the height of equilateral triangle. If not, I'm rubbing this one. Okay. Ish. Let's take another color. we require this one, right? So this is 60 degree, right? So this side will be what? 60, what, cos 60 or sin 60? Will be sin 60, right? So 6, it will be a sin 60 here, right? So a sin 60 is root 3 a by 2. If you don't know, write that down somewhere, that the height of an equilateral triangle is root 3 by 2 a, where a is the side of the triangle, right? Okay, where is the pen? Right, so it is root 3 by 2 a, this height. So I got the x-axis as how much? A by 2, this length, right? And this will be the height, right? So root 3 by 2 a, right? That is the coordinate of this one. So you got the coordinates, you just have to find the xcom and ycom. Center of mass x coordinate is m1, as m into x1 is 0 plus m into a plus m into a by 2 whole divided by 3m, sum of the masses. This guy goes off, it is 3 by 2 ma divided by 3m. You will get the answer as a by 2, right? So center of mass, this one I'm going to rub off, right, is having x coordinate as a by 2. So a, what is a by 2? This here, right? This is a by 2, right? Now for y coordinate, again y center of mass is equal to m into 0 m1 y1 plus m2 y2 plus m3 y3, right, divided by 3m, right? So what will be this value? These two goes, right? Then there is root 3. Now the calculation, you will get a by 2 root 3, right? That is a y coordinate of the center of mass. So y coordinate root 3a by 2 will be quite close to here. This is the y section, right? So it is close to here. So the center of mass is here, right? The center of mass is having coordinate as x as how much? A by 2, and y coordinate as a by 2 root 3. Clear? This is how you do the calculations. Okay, now we are going to do a difficult one. Again, I will give you tricks for solving these questions. Okay, while doing your school examination, better write the entire formula, etc. But I'm giving you a trick for solving this type of problems. Okay, I will to give you a trick, then we'll go for the problems which I'm going to do. Okay, suppose there is a system, right, of only two particles, right? This is m1, this is m2. Again guys, it is a trick for doing your need questions, etc., right? And you are asked what is the center of mass if these two masses are at a distance r from each other. So you will do the calculation as like this. Now you will take one as origin, the other will be r0, etc., right? So you will write x center of mass, there is only x, there is no y, is equal to what? m1 r1 goes off now, there is only m2 r2, which is r, divided by m1 plus m2, right? Can't you mug up this equation as it is, right? So this x center of mass, right, the position of center of mass, this is measured from m1, right? So center of mass position from m1 is equal to the other mass, right, m2, into distance between those two masses is r, divided by m1 plus m2. See, the same question if I am going to form when this is m1 and m2, and if I am going to take this guy as origin, then I can say x center of mass, this is the origin, or the m2 I am going to take this origin, then I will write m1 into r divided by m1 plus m2, right? So from whom you want to make the center of, from whom you want to measure the center of mass, that is the guy who becomes the origin, right? So you have to write the equation in such a way that x center of mass is equal to the other mass. You are taking m2 as origin, so the other mass is m1, m1 into r divided by m1 plus m2. Simple, right? I'll do a small problem, right, with the same criteria we have done. Let's say this is m, right? There is another mass 2m. Let's say they are at a distance d from here. So what is the center of mass of location from this mass. So you can just from m. Okay, so if this becomes m, or this m is taken as origin, so the equation is this guy, that is 2m. The distance between these guys is d, divided by 2m plus m is 3m. So you can straight away write it as 2 by 3d. That is center of mass from here, na? So this 2 by 3d is larger, na? Right, so 2 by 3d will be here, right? Center of mass is 2 by 3d from this guy, right? Now same scenario, if I'm going to talk about the center of mass from 2m, right? There's a position of center of mass from 2m, right? This is for 2 from 2m, this is from m. So this guy I'm going to take the origin, means I have to take this guy as m2, right? So m into d divided by 3m, so it becomes d by 3. So this center of mass is d by 3 distance from 2m. It is at a distance 2 by 3d from m. See, you need not write the entire equation, you can calculate within fraction of seconds, right? Similarly, if you are having 2 kilogram here and the 6 kilogram here, right? Let's say it is 4 meter away from each other. You're asked what is the center of mass from 6 kilogram. What is the position of a center of mass from 6 kilogram means, you can just write it as what? You want the position from 6, right? So write 2. 2 into 4 divided by 6 plus 2 is 8. That is 1. So the center of mass is at a distance 1 centimeter from 6 kilogram. Yeah, right? This is very important concept, or very easy to calculate question. Okay, now similarly there is another concept I want to make sure you understand. Same m1 and m2, two system or two particle system. Let's say they are at a distance r from each other. Let's say we have already found the center of mass here, and the position of center of mass from m1 is r1 and position of center of mass from m2 is r2, right? This much clear? Now what can I say about r1? Position of center of mass from m1, right? So I can write it as m2 into what? R divided by m1 plus m2, right? Similarly, what is r2? Position of center of mass from m2. So that is m1 into r divided by m1 plus m2, right? Right? We just talked about it. So what is m1 r1? It is what? m1 into this term. It is m2 r divided by m1 plus m2. What is m2 r2? Just multiply m2 here. That is m1 m2 r divided by m1 plus m2, right? Now guys, don't you see that both of them are having same RHS? Yes. So you can write mass into its position from center of mass is equal to mass into the position of that mass from its center of mass. This is not there in your NCERT. This is something which you are taught in the case of NEET as well as entrance portions, right? m1 into r1 is equal to m2 r2, right? Where r1, that is, I'm redrawing the figure again. This is m1, this is m2, this is center of mass, right? If m1 is at a distance r1 from the center of mass and m2 is at a distance r2 from the center of mass, then m1 r1 is equal to m2 r2. Now why I have taught this section is, it's very easy to solve some of the problems by this method. That's why. See, you are having a rod like this. Let's say this rod is having mass m and length l, right? Another rod is kept below to it like this, right? It says that this rod is also having mass m and l length, right? And you're asked what is the center of mass of this entity. How would you do? So this mass or this rod, what will be the center of mass? Will be, it's exactly at its center, L by 2, L by 2, right? So this becomes the mass, and you know that the mass will be concentrated at one point. For a uniform object, the mass will be concentrated at the center, right? So this becomes the center, and this center is at location L by 2 here, right? Now here at the center itself there is another rod. Now this rod will be also having its center of mass located here, right? right? So that means, and its mass is concentrated at this point, so I'm going to redraw this as 2 points here. This is mass m and this mass m here, and they are at a distance L by 2 from each other, right? Now equal masses, right? Where will be the center of mass? It will be half the position of the here, so that will be L by 4. See, you solve the question fraction of seconds, right? So the center of mass will be L by 4 from either sides. Clear, right? I hope this much is clear, right? Now another type of question which is usually asked is, suppose there is a 6 kilogram block, right? And okay, I'm drawing that, right? So there are two, this is 6 kilogram and this is 2 kilogram, right? And they already have a center of mass location we are not going to talk about, right? So if the 6 kilogram mass is moved 2 meter towards right, by what distance should the 2 kilogram has to be moved so that the center of mass remains here itself? Again, the question is 6 kilogram mass is supposed to be moved to the right by 2 meter. So in order to keep the center of mass here itself, the 6 kilogram mass should be moved to which direction? That is something sure. If you want to keep this center of mass here itself, if the 6 kilogram when shifts in this direction, the center of mass also shift, right? So in order to keep that as constant, that means 2 kilogram should be also, should be moved in which direction? Okay, in which direction the 2 kilogram has to be moved? It should be moved in left direction, right? It is pulled in this direction to compensate it. 2 kilogram has to be moved in this direction. That much is for sure. Now we are going to show it to how to calculate it, right? So see, you know m1 r1 is equal to m2 r2, right? M1 is the mass, this one, R1 is the position of this mass from the center of mass, and M2 is 6 kilogram and R2 is the position of its center of mass, right, from M2. So what happens if I find change in position, right? Initial position and find position, right? So before going to that one, let us write the equation about which you are thorough about, right? As a position of center of mass, that is XCOM is equal to M1 x1 plus M2 x2 divided by M1 plus M2, right? Now if suppose the position is changed by a little bit, means the change of center of mass also will be very small, right? Let us write it as dx, right? So this will be change in the small position, change in the case of mass m1 center of mass position plus m2 into dx2, right? Its position also changes, divided by m1 plus m2. Mass is not going to change, only the position changes. So I can write here, in this question you are told that the center of mass shouldn't change, means that this dx should become 0. There is no change in the center of mass. So m1 dx1 plus m2 dx2 will be equal to 0, because this will be also equated to 0 now, right? So I can write m1 dx1 is equal to minus m2 dx2. This is the equation which is very helpful while doing this problem, right? We'll go for the same problem here. So this is 6, this is 2. 6 is to be changed by a position of 2, right? Whereas 2 is to be changed by a position you don't know. Okay, I'm not going to take the direction. We'll talk about this now. That is, let's say this direction I'm going to take it as positive, x direction. Then this direction will be negative, right? So if you are moving to the right, it is positive, to the left it is negative. This much clear? Now that means 2 into dx1, I don't know how much the 2 is going to be changed, is equal to minus m2, that is 6, into dx2, how much it is? 2. I'm taking this direction as positive. So dx1 is equal to minus 6 you will get, right? Minus 6 means if this direction is positive, that means 2 would have moved in this direction by 6 meter, in this direction. I hope this much is clear. So when you are moving 6 kilogram in this direction by 2 meter and you want to maintain the center of mass here itself, then the 2 kilogram mass should be moved by minus 6 centimeter, or I can say should be moved to the left by 6 centimeter. Clear? No, the same type of question can be easily twisted and asked, right? That is, you can be asked the same 2 kilogram and 6 kilogram, right? Again, you are moving 2 meter in this direction, 6 kilogram, right? So you're asked by how much meter or in which direction and how much meter the 2 kilogram should be moved so that the center of mass also shifts by 3 meter towards the right. Right, the question changed. You don't want the center of mass to be fixed. Alright, so that means you want the center of mass also to be shifting 3 meter further, right, from its initial position. So you know what is dxcom, that is what, m1 dx1 plus m2 dx2 divided by m1 plus m2. Now this is not 0 because there is a position change in what, our center of mass. Why, how much it has to be shifted? Disturbed that 3 to the right, so this direction I have taken positive, so 3. M1, what is the M1 mass? Let's say it is 2, right? Sorry, okay, 2. And what is the position change of 2? I don't know, that is what you are supposed to find. Plus M2, what is M2? 6. How much it is shifted to right? It is shifted by 2. M1 plus M2 is 2 plus 6, that is 8, right? Now it is solvable, right? 24 is equal to 2 dx1 plus 12, right? That is 2 dx1, or I can find dx1 as equal to 6 meter. So 6 meter is in positive, means the right direction, right? So that means in the same figure, when the 6 kilogram is shifted to 2 meter further in right direction, and suppose this is center of mass, the center of mass also will be shifting by 3 meter if you can move 2 kilogram in 6 meter in the right direction. That is, when 6 kilogram moves in with 2 meter and 2 kilogram is shifted by 6 meter, then the center of mass will be also shifting by 3 meter. Is much clear, right? Let us look at another problem. I have already drawn the figure, right? You are having equal to m masses on this side of a cube and m mass on this side of the cube, and each side of the cube is of a centimeter or meter whatsoever, right? And you are asked what is the center of mass of this section. So you can either use the lengthier process of finding xcom, ycom, zcom by equation m1 x1 plus m2 etc etc, or you can use the method which I have told you. So I have already drawn the answer here because as you can see the time is going on finishing, right? So what we are going to do is, see, I've taken this surface, right? So this is a uniform surface, so its center of mass will be here, around here, right? Only of this surface, guys, right? And the mass will be what, 8m, that is 2m plus 2m plus 2m plus 2m. 8m will be concentrated at this center of mass, yes. Similarly, I have taken this surface, right? That surface is having another 4 masses, right? So 4m is concentrated at this face, right? So I have taken these two center of masses, okay. I have separately drawn the center of mass 8m and 4m, which is along this line, so that the center of mass of this entire body will be lying between 8m and 4m. 8m and 4m. So if I draw, this is the position of 8m, this is the position of 4m, and the center of mass might be lying somewhere here. We don't know, right? So we got two masses, right? You made this entire 8 mass system into 2 mass system, right? So and you require, and you have found the mass of the 2 mass system also, that is 8m and 4m. You now require the coordinates of these masses, right? Right. So how can I find this coordinate? For this point's coordinate, this is the distance from what? This axis is along x, right? So x axis, how much is this position? Half of a, right? From here to a, it is a. So x coordinate is a by 2. Now this side, right? This is y coordinate side, right? This is a y coordinate side. So this is also y coordinate side. This is also half, right? This point is along half of the y coordinate, hence y coordinate is also a by 2. What will be z coordinate? This face, this face is at a distance a from z, right? Along this plane, if you are saying it is shifted by a, so z coordinate is a. So for 8m, I'm going to write the coordinates a by 2, and a, right? For 4m, similarly, you can write the coordinates, write this, right? So this is at a distance along the x-axis, the coordinate is a by 2. Along y-axis also it is a by 2. In the z-axis, there is no coordinate for it, so it is 0, right? It is origin, right? Along z, it is coordinate is 0. So for 4m, I will write the coordinate as a by 2, and 0. Now you have two masses with 3 coordinates. You can easily find what is xcom. It's very easy now. Xcom will be, see, position is same, right? So xcom and ycom will both be a by 2 itself, right? What will be z's coordinate? If you want, you can calculate m1 x1 plus m2 x2 divided by m1 plus m2. You will get a by 2 itself. Now x coordinate, center of mass will be what? You can write just this coordinate and this coordinate is required, right? Or you can just write like this, 8m, sorry, this is 4m, this is 8m, right? So you have to find the center of mass, right? Let's say it is distance from 4m I will take. So it is this mass 8m into the distance between these two guys is a, right? Divided by 12. 8 plus 4 is 12, right? 12m cancel. So it will be 2a by 3, right? So ZOM is 2a by 3 from 4m. So the coordinate of the center of mass is a by 2, and 2a by 3.